Hi, Science 7. Today we're talking about topic 4, expansion and contraction. And as you recall, we've heard of the particle model that says all things are made of tiny particles that have spaces between them, and these little particles are always moving a little bit differently in solids, liquids, and gases. And so that's what we're talking about today. And as you recall, if the temperature goes up, the motion of those particles increases. You can check out the Do You Know activity, but we're going to talk about expansion next, where we know that if you have a warming up, particles will get further apart and expand, and their volume increases as you see in the diagram. You can think of boiling a pot of water, and if it had the lid on, the lid would start popping off because those hot particles will start taking up more space, and the lid of the pot will start popping off. Contraction, on the other hand, as you cool down a substance, the particles will start moving slower, and then the particles will be closer together and take up less volume. There are the 3 states of matter: solid, that cannot be compressed, and the material stays the same size and shape. With liquids, the liquid will take the shape of a container but cannot really be compressed like the solid. And then there's gas that has no shape, has no volume, and you can squash a gas because of all the particles in it. Looking at how particles move, we'll go to this slide. In a solid here, those particles are pretty packed together, so they will vibrate as the temperature changes. In a liquid, those particles will be able to rotate. They're held together fairly loosely, little space between them. And in a gas, those particles have large spaces, vibrate, rotate, and even travel long distances between them. Solids will contract and expand at different rates depending on what solid it is, and they have a certain shape and certain volume that cannot be compressed. This has to be taken under consideration as construction and engineering of any buildings or roadways takes place, because we have to make some allowances for that expansion and contraction. As you can see in this picture here, if we take at 0 freezing, 100 centimeter different substances, most of these are metals here, you notice that they will all, at minus 100, they will all be, that 100 centimeter length will all be smaller. At 100 degrees positive, 100 degrees Celsius, when it's almost boiling, it will expand. So this is across the board for all these solids, even if they're not metal, so glass and Pyrex, they still contract when they're frozen and expand when they're hot. Here's a picture of railway tracks that went all funny because of the expansion and contraction in different temperatures, which is why allowances have to be made now like this, where they have to allow for the expansion contraction in different temperatures, especially where we live, where it can go anywhere between positive 40 and negative 40 and then some, so that's 80-degree difference at least. So if there's joints that allow that for that expanding and contraction, they're called expansion joints. Moving on to liquids. Those liquids have a certain volume in no matter what container you put them in, but you cannot compress them, and they take the shape of that container. Different liquids can also expand at different rates. One thing we can think about is the lab thermometer, that if you put it into something warmer, a beaker that's warmer here, the liquid will expand and actually rise to whatever temperature it is, and that's how it works. but that's what it's calibrated to do. But it just shows you that warmer liquids will expand. Moving on to gases, they will take the size and shape of their container, and if they are warmer, they will take up more space. So this piston here is loose, and when you heat up the container, the piston went up because the gas took more space. If you put a balloon on a bottle and heat that water, like in boiling water, this is what the balloon can do, because that particles in there will take up more space. Our last type of state of matter, plasma, is something that happens or occurs or found in really, really high temperatures, like the sun, or like in lightning, or northern lights, or neon signs. And we've got particles that break up into electrons and ions, and basically plasma is this electrically charged gas. And that is the end of our topic. A couple videos for you to check out and some review to do in your notes. And I will say bye for now.